We got the line here, the given line, x minus 1 by 2, y plus 1 by minus 3, and z minus 0 by 1. That is our given line here. 7, 11 minus 4. 7, 11 minus 4. This is our interested point. We are interested in this point, 7, 11 minus 4. Now we are interested to find the shortest distance between these two lines. That is the red line and the yellow line. So let us remove the other elements. Let us find the shortest distance between these two lines. Welcome to this video. In this video, we'll try to solve the 3D geometry question that came on JEE Mains conducted on 22 Jan 2026, Shift 1. The question is as follows. Let point P of alpha, beta, gamma be the point on the line at a distance for root 14 from the point 1 minus 1 0 and nearer to the origin. Then the shortest distance between the lines. Here alpha, beta, gamma is given in the first line. Second line is given is equal to. So this is a two-part question. In the first part, we need to find the values of alpha, beta, gamma by using the distance formula from the point 1 minus 1 0. And then after finding alpha, beta, gamma, we will define these two lines, and then we need to find the shortest distance between these two lines. Okay, now let's start doing the question. Now we will plot the point, and let's start by plotting the line first. We got the line here, the given line, x minus 1 by 2, y plus 1 by minus 3, and z minus 0 by 1. That is our given line here. Now we need to find the point P. The point P that is at a distance of 4 root 14 from the point 1 minus 1 0. So here 1 minus 1 0 is here. The point P of alpha, beta, gamma is at 4 root 14 from this point and is also in the given line. Okay, let's start solving this question. So any point on the line is, so let us again write it here. It is x minus 1 by 2 is equal to y plus 1 divided minus 3 is equal to z by 1. Let it be lambda. So any point on line will be 2 lambda plus 1 minus 3 lambda minus 1, and it is lambda. So let P of alpha, beta, gamma be this one. Now we will apply the distance from the point 1 minus 1 0. So that is, if you are applying the distance, it is square root of 2 lambda plus 1 minus 1, that is 2 lambda whole square, plus minus 3 minus 1 minus 1, that is minus 3 lambda the whole square, plus lambda minus 0, that is lambda square. So from this point we are calculating the distance to this point, and that distance is given as 4 root 14. Okay, we will expand that. Is 2 lambda square, it is 4 lambda square. Three lambda the whole square, it is 9 lambda square plus lambda square by Squaring on the both sides, we can write it 4 into 14. It is 16 into 14. Here it is 14. Lambda square is equal to 16 into 14. 14 and 14 can be cancelled. Lambda square is 16, so lambda will be plus or minus 4. So if lambda is plus or minus 4, we'll be having 2 points exactly. So this point can be towards this side, 14 root 14 towards this side or towards the other side. So in the question, it is mentioned that the particular point P, we need to consider the particular point P that is near to the origin. So let us take the 2 points here. For lambda is plus 4, lambda is equal to plus 4. So P will be, it will be like this 2 lambda plus 1, that is 9, minus 3 lambda, that is minus 12, minus 1, that is minus 13. Lambda means 4. Then 4, lambda is equal to minus 4. Then P will be minus 4, minus 8 plus 1, that is minus 7. Minus 3 into minus 4, that is plus 12, minus 1, that will be 11, and lambda is minus 4. So we need to calculate the distance of these 2 points from the origin. So for first point, it will be square root of, I'm doing it here, square root of 9 square is 81, 13 square is 169, and 4 square is 60. For the second one, we calculate, it is 49 plus 121 plus 60. So we know that by checking here, we know that this is having more value. So we need the point that is nearer to the origin. So that point will be minus 7, 11, minus 4. So alpha will be minus 7, beta will be 11, and gamma will be minus 4. So the first part of our question is over. We got alpha, beta, gamma. Now we will proceed to the second part. So we need to define these 2 lines. So let us proceed here. We'll define those 2 lines here. Okay, here in the animation we have added the 2 lines. I have already told about the 2 points here. 9 minus 13 4. 9 minus 13 4, that is towards this side, and 7 11 minus 4. 7 11 minus 4. This is our interested point. We are interested in this point, 7 11 minus 4. Now we will proceed to the next part of the question. So the 2 lines, one line is passing through this point, that is minus 7 11 minus 4, and the other line will be this line, x plus 5 by 2, y minus 10 by 1, z minus 3 by 2. Now we are interested to find the shortest distance between these 2 lines, that is the red line and the yellow line. So let us remove the other elements. Let us find the shortest distance between these 2 lines. So from this animation we can see that both these lines are skew lines. So for skew lines, what is the formula? The formula of shortest distance is A2 minus A1 dot product B1 cross B2 divided by magnitude of B1 cross B2. This is also magnitude we'll take. So that is the shortest distance between these 2 lines. So what is A1 A2 here? A1 and A2 are the corresponding fixed points that is given on these two lines. And B1, B2 are the direction ratios. For example, B1 here will be 1, 2, 3. That's the direction ratio of the red line. B2 will be 2, 1, 1. That is the direction ratio of the yellow line. So we will try to understand the real meaning of this animation, of this equation. So what is A2 minus A1? A2 minus A1 is the line segment from point A1 towards point A2. Let's add that. So this line segment is A2 minus A1. So we'll find it out. A2 minus A1. So A2 is here. A2 is minus 5, 10, 3. That is minus 5, 10, 3 minus 7, 11, minus 4. So what is A2 minus A1? That is 2, 10 minus 1, minus 1, 3 minus 4, 7. A2 minus A1 is this value. That is A2 minus A1. Now we need to find B1 cross B2. So I have already explained that B1 and B2 are the corresponding direction ratios of the two lines. So we will add those direction ratios, some vectors signifying those direction ratios here. So B1, the direction ratio, the B1 vector will be along towards the direction of the first line. The B2 vector will be towards the direction of the second line. So B1 cross B2 means it will be the area, the magnitude of B1 cross B2 will be the area of the parallelogram that is created by B1 and B2. So here, magnitude of B1 and B2 will be the area of the parallelogram. So what will happen when we dot product an area towards a height element? We will be getting a volume element. So here, this is a parallel pipette where the base is created by vectors B1, B2, and the height element, the slanting height, is created by the line segment A2 minus A1. So here in the equation of the shortest distance, the numerator part, A2 minus A1, which is the height part, B1 cross B2, which is the parallelogram part. So when we are dotting these two, the numerator becomes the volume of the parallelepiped. So the numerator becomes the volumes of the parallelepiped, and the denominator, that is the area. So if you are dividing volume by area, we'll be getting height, and that height is the shortest distance between these two lines. Okay, we will come back again. We'll try to solve it. Let's solve B1 cross B2. Here B1 is 1, 2, 3. 1, 2, 3. B2 is 2, 1, 1. So B1 cross B2 will be that will be I cap into 2 minus 3 minus j cap 1 minus 6 plus k cap 1 minus 4. So that will be minus I cap plus 5j cap minus 3k cap. We need to find the magnitude also. So magnitude of B1 cross B2, that will be square root of 1 plus 25 plus 9, 1 plus 10, that is square root of 35. So now we will see the dot product of A2 minus A1 into B1 cross B2. So A2 minus A1 into B1 cross B2. So A2 minus A1 is A2 minus 2 minus 1, 7. So that is 2 minus 1, 7. Dot product of here B1 cross B2 is minus 1, 5, minus 3. Minus 1, 5, minus 3. So it is minus 2, minus 5, minus 21. So that is minus 28. So the shortest distance will be minus 28. We'll take the value only, magnitude only, 28 by root of 35. We'll come back to the question. 28 by root of 35 is not in the option. We'll try to figure out some value. So 28 is 7 into 4, and here it is root of 7 into 5. We will 4 by 4 root of 7, if you are removing, it will be 4 divided by root 5 into root 7. 4 root 7 by root 5. 4 root 7 by root 5. So I think this is the answer. 4 into root of 7 by 5. So coming back to the animation. So we have calculated this as per formula. Now let us try to figure out the geometric interpretation. So we got the parallelepiped. The numerator, as I said, is the volume. The denominator is the area. Volume by area is the height. Now, see here, this is I have rotated this. Now we are having an idea. This is the area here. This is A2 minus A1. So when we are dot producting this area to this landing height, we will get the volume. Now dividing this by area, that we will be getting, this is the height of this parallelepiped, and that height is the shortest distance between these two lines. So one thing is knowing this formula by heart. Another thing is having an idea of what this formula is about. So I hope I was able to give you some idea about the shortest distance formula of a skew line. So that is it. Hope everybody understood it. This question was solved. We got the answer. Then we will see in the next video.